Alrighty guys, this is the tutorial video for arithmetic sequences. So our topic again is arithmetic sequences. If you look at that first word, arithmetic, it looks a lot like the word arithmetic. Or you could say it's arithmetic sequences, arithmetic sequences. I've heard it pronounced both ways. So when you think about arithmetic, that's your adding, your subtracting, multiplying, and dividing. So we are looking, kind of going back to the basics and seeing patterns throughout a number set. So if we have an arithmetic sequence or an arithmetic sequence, all right, the definition for that is a sequence in which the difference between any two consecutive terms is constant. So that means it is either increasing by a constant amount or decreasing by a constant amount. The common difference, the definition for that, is going to be the numerical difference and we call it D, right, between any two consecutive terms. And remember, the word consecutive means one right after the other. So 2 and 3 are consecutive numbers. 10 and 11 are consecutive numbers. So numbers in a row. Those are consecutive. However, in a sequence, it would be the first term and the second term, or the third term and the fourth term. So the number that comes next is consecutive. So we are going to go through and practice a little bit about identifying an arithmetic sequence, all right? So if we look here, we are trying to look for a pattern. Again, that pattern is using addition or subtraction, all right? And then it says, determine whether the sequences are arithmetic. If so, or if yes, identify the common difference. So here, if we look, how do we get from 1 to 5? Well, we add 4. From 5 to 9, we add 4. And from 9 to 13, we add 4. So this one is an arithmetic sequence, and D is equal to a positive 4. For number 2, if we look, to get from 1 to 3, we add 2. From 3 to 5, we add 2. But from 5 to 8, we add 3. So because that is not a constant difference, it cannot be an arithmetic sequence. For number 3, if we look, from 8 to 6, we subtract 2. From 6 to 4, we subtract 2. And from 4 to 2, we subtract 2. So this one is also yes, but this is our first example of a negative D value. Go ahead and see if you can identify the patterns for 4, 5, and 6. So if you go ahead and check your answers, 4 and 6 are arithmetic sequences. For number 4, d is equal to -3, and for number 6, d is equal to -1, so those both use subtraction. However, for number 5, it is not, because it is multiplying by 2 on each one. If it is multiplying by 2, that is not a constant difference. So then, if we're looking at continuing arithmetic sequences, you have to identify the pattern and then find the next 3 terms. So I'll go over number 1 together. Well, I guess it's number 7. And then you will do 8 and 9. So if we look at number 7, if we look here from 9 to 13, you add 4. From 13 to 17, you add 4. And from 17 to 21, you add 4. So we need to add 4 to find the next 3 terms. So 21 plus 4 is 25. 25 plus 4 is 29. And 29 plus 4 is 33. So that in that arithmetic sequence, d was equal to that positive 4. You go ahead and try 8 and 9 for me, please. So again, if we check our answers for 8 and 9, for number 8, d was equal to -3, so my next 3 terms are -7, -10, and -13. And for number 9, d was equal to a +6, so my next 3 terms were 16, 22, and 28. So there is a special formula that we go ahead and we use for calculating arithmetic sequences and finding the nth term or a specific term in that sequence. So the formula is, we have a(n) is equal to d times n minus 1 plus a1, where d is the common difference and a1 is the first term of the sequence. So let's go over some examples. If we look down here at number 10, we first need to find our a1 and our d. So a1 is the first term, so our first term is 7, so a1 is 7. Then we need to find the pattern. From 7 to 13, we are adding 6. From 13 to 19, we're adding 6. And from 19 to 25, we are adding 6. So d is equal to 6. So in our equation, what we will do is we will use our formula. a(n) is equal to d, which is 6, times n minus 1, and then plus 7. So what we are going to do now is we are going to simplify our function. When we simplify our function, we are going to use the distributive property. And so we get a to the n is equal to 6 times n, which is 6n. 6 times -1 is -6. And then we bring down that positive 7. So when I combine my like terms, I end up getting a to the n is equal to 6n plus 1. So this is my sequence. Then it says, after we do that, we are going to find a to the 19th, which means the 19th term in that sequence. So I plug in, I substitute in 19 for n. So here I would have a to the 19th is equal to 6 times 19 plus 1. And when I simplify that out, I end up getting 150. So I want you guys to go ahead and try number 11 for me, and then go ahead, pause the video, try it out, and then we'll go over it. So if we look at number 11 here, the first thing, again, remember we have to identify our A1 and our D. A1 is our first term, so that is 30. And D1 is our difference, so if we look, we are subtracting 4 from each, so D is equal to negative 4. When I plug it into my formula, I end up getting negative 4 times n minus 1 plus 30. When I go ahead and I simplify using the distributive property, I get a to the n is equal to negative 4n plus 4 plus 30. I'm going to combine my like terms, so a to the n is equal to negative 4n plus 34. Then they ask us to go ahead and find our the 19th term in that sequence. So when we go ahead and we try to find the 19th term, we are plugging in 19 for n. And when we do that, you will go ahead and get negative 42. So I want you to go ahead and try 12 through 15 for me. And then once you think that you have attempted all of those and you want to check your answers, go ahead and play the video again. So if we go ahead and we look at 12 through 15, for number 12, your answer is a to the n is equal to 3n minus 14, and the 19th term is 43. For number 13, your sequence is denoted by 2n minus 4, and the 19th term is equal to 34. For number 14, your sequence can be described as negative 5n minus 11, and the 19th term in that is negative 106. And then for number 15, you go through, and your sequence can be denoted with a negative 9n plus 110, and the 19th term in that sequence is negative 61. So a lot of times when you are doing and using this formula, it is a shortcut for going ahead and predicting future terms in the sequence. So I'd like to go over the real life application problems with you. I want to go over number 16 with you, and then you will do 17. So if we look at number 16, it says you visit the Grand Canyon and drop a penny off of the edge of a cliff. The distance the penny will fall is 16 feet for the first second, and 48 feet the next second, 80 feet the third second, and so on. So if we look, it says write a formula to represent this sequence. So if we look at the set of numbers, we have 16, we have 48, and we have 80. If we look here, the difference between each number is a positive 32. So D, or our difference, is 32. The first term in our sequence is 16. So when we go through, that means that A1 is equal to 16. We are going to complete our formula. So we have a to subscript n is equal to 32 times n minus 1 plus our a1, which is 16. So when I go through and I distribute, I get a to the n, or a subscript n, is equal to 32n minus 32 plus 16. when I go to combine my like terms, I end up getting the formula 32n minus 16. So this describes my sequence. When it asks us how far the penny will travel after 6 seconds, that is saying that we are looking for the 6th term. So then we will be plugging in 6 for n. So I will multiply 32 times 6, subtract 16, and my answer will give me 176 feet. So again, my answer is 176, and that is talking about how far it travels, so that is going to be feet. So please make sure to end the video, to end your practice on this section. You are going to go over number 17, an additional application problem. If you have any questions, please make sure that you email me or reach out to me on Google Classroom. With that, the next thing that you are to be doing is your homework number 5. The homework number 5, part of it covers the sequences, and the other part is going to cover a quiz review. Please remember that your quiz 3-2 is a take-home quiz that is to be done by yourself. Please review those guidelines that are on the front of your assignment packet, and you will go ahead and you will complete that to be able to turn in on Wednesday. Remember, this entire assignment packet is due on Wednesday. Thank you for watching the video. Hopefully you understand sequences a little bit better now, or at least the arithmetic sequences. And if you have any questions, please email.